In this video I'll show you how to use a little op called data picker that will let you get the data from Corp in a PDF or an image that then you will be able to use easily in a Data Optimizer or any other tool. So we begin by opening a Parameter Optimizer, and we see here in the Data tab a button called Data Picker. If you press it, you will access this little app. The way it works is, let's imagine you have this catalog for this IGBT, and you want this curve, for example, for 12 volts. So what you would typically have to do would be to go voltage by voltage, for example, for 2, 3, 4, and so on, and picking the current and putting them, for example, in Excel, and then saving as CSV or whatever, and then open it in MATLAB. But you can see how this can take a lot of time if you have to do it a lot of times. So it's better just to, my advice is to just use Data Picker, since also the data you will get will be much more precise than the one you could get by eye. So let's begin by using it. We can copy this image, for example, with the snipping tool. We open it, copy it, for example, we save it in the desktop. Okay, here it is. And from Data Picker we press Load Image, and then in the desktop, just like this. We could also have copied to the clipboard and press the clipboard button, is the same. Anyway, so what you need to do now is just to set the, you just need to set the axis limits. So not really the axis limit, but you have to set 4 different points, 2 in the x-axis, 2 in the y-axis. So what you do is you move with these sliders. For example, you put it here, and this y value here is 200, so you put here 200. Then you move the other one, for example, up to here, and you put it's 0, so just put 0. Here you put this one here, 0 again. You could also put it here, it doesn't matter. Like you just need 4 points. You could put it like this, you know, like this means this here is 2. It's the same as putting this one here and saying it's 0. And then the other one. Okay, so basically what you have done now is you have this image and you have said, okay, this point here, like this line here is 200, this line here is 0, this line here is 2, and this one here is 10. So now if you press select points and you start clicking, let's say you want the 12 voltage curve, you just start clicking. Every time you click, you add a point. Okay, so if when you finish, you just press enter, and you can see here the red are the points, and the pink is the interpolation using linear interpolation, which will be exactly the same that the Parameter Optimizer will see. So now that you finish with this curve, what you have to do is you just press export, and let's save it in the desktop so we can see it easily. Just put a name, and here it is. It will create a TXT file with 2 columns, as it can be easily read by Parameter Optimizer. First column is the x values, and second column is the y values. You can see, for example, this point here is around 160 something, and you can see the last point is 160 something. Has just taken all the points from the graph, and you have them in the TXT file. We can plot it now if you want to see that you got what you wanted. Yes, also you will see them here. Okay, here we have the data in the TXT file, and if we plot it, we'll see how it's what we want. So here we are. This is exactly the same. This is the data in the TXT file. You can see that you save the points you selected in the tool, and all the points saved are as you wanted. Like it starts at 0, it goes up to 10 here and 160 something. You can see it's the same curve. The advantage of doing this is that first it takes, I would say, it takes quite less time than doing it by hand. Second is the precision you get, because when you do it by hand, for example, this point here, I don't really know what it is. I know it's between 150 and 175, but that's almost as good as you can get. The tool, on the other hand, will do a linear interpolation, will get the best value you can get, much better than you can do by eye. So it's advised to just use this tool, because you cannot expect, for example, if you do this by hand and you have let's say you have a 5% error, because your eye cannot really see what's the true value. So your curves will have a 5% error. So I guess you cannot really expect to have a fitting better than 5%, because your curves are already broken 5%. So I guess you will get results like, for example, 10% error. And the curves we're getting right now, for example, are getting around 2 to 3% in the dynamic ones, and around 4 in the static ones. So if we were not using this tool, we would get much worse results, like, for example, 7 or 8% error, since all the points taken would have such a big error. Okay, so thank you for your time. I hope you like this tool. If you have any doubts, again, just go to the website, but you also have a help button here with all the information. It describes the same thing I did before. Thank you for your time.